Okay, so today we're going to talk about municipal solid waste, what we typically think of as waste or trash. And we're going to talk about how it's disposed of, how it can be recycled, and how we can reduce the amount of waste that we create. So let's just jump right in and find our PowerPoint here. Okay, we're going to start by talking about solid waste disposal. So this scene is from Mad Men. Some of you might have watched this television show. And I find it fascinating simply because in today's day and age, if somebody did this and left this litter all over the ground, everyone would be astonished. And it's such a taboo. And yet in the 1960s, it really wasn't. So our world has changed for the better in terms of our awareness of our environment. But it's still important to talk about how we dispose of solid waste. And this section of this unit feels a little bit displaced sometimes, but one of the reasons that we talk about solid waste when we talk about aquatic pollution is, well, for one thing, College Board combines aquatic and terrestrial waste, but also any waste that isn't properly disposed of usually eventually finds its way into the water. And so garbage, sludge, plastic bottles, all of that stuff finds its way into our oceans. And particularly the Pacific Ocean, because the Pacific Ocean covers a huge portion of our globe. And so you guys may have heard of what we call the Great Pacific Garbage Patch. It's actually two substantial patches connected by what they call a convergence zone. And the gyres or the currents of the ocean kind of hold the garbage in those locations. And this is all waste that hasn't been disposed of properly. And when you look at what's found, number one, cigarettes. Number two is food wrappers and containers. Number three is bottles, water bottles, Gatorade bottles, any kind of beverage bottles, but plastic bottles. And then followed closely by plastic bags. So you'll notice that the vast majority here, the top four, actually the top five, are all plastics. So proper disposal of waste is important as far as terrestrial pollution, but also as far as aquatic pollution. And we've already talked about the fact that litter in the oceans can cause all kinds of issues for our aquatic species. So where are we supposed to dispose of it? Well, in the modern world, we dispose of what we call municipal solid waste. So municipal solid waste, municipal means of the city. So waste from our cities and our towns goes into what are called sanitary landfills. So a sanitary landfill is one that is permitted and follows a certain set of rules as far as minimizing impact on its environment. And we're going to talk about that. So there are really two main issues with landfills. One is what we call leachate, and the other one is gases. So when we talk about leachate, we're talking about that contaminated water. It's percolating down through that pile of garbage. It's passing through that municipal solid waste, and it's eventually winding up in the soil, and therefore eventually in the groundwater or in the waterways. So any material in the municipal solid waste that is water soluble is going to wind up in this leachate. So we're going to talk about how leachate is contained. And then the landfill itself will actually generate gas. At the very beginning, as a landfill is being created, we have aerobic decomposition, meaning decomposition in the presence of oxygen. And that decomposition is going to generate carbon dioxide. This is a short phase, not a significant contributor to CO2, although it is somewhat a contributor of carbon dioxide. The more significant gas from landfills is methane, because once a landfill goes through the first couple of phases, it reaches anaerobic decomposition. And when we have anaerobic decomposition, instead of creating carbon dioxide from the breakdown of organic material, we create methane from the breakdown of organic material. This obviously does not need to be memorized in any sort of way, but I think it's interesting to see how the gas concentrations change over time. This fourth phase, this anaerobic phase, during where methane is generated, begins after less than a year in a landfill and can last for up to 20 years. Carbon dioxide levels usually go down because that production of methane actually converts some of the carbon dioxide into methane. Okay. So what's a landfill look like? Well, this is an image of a sanitary landfill. So a sanitary landfill, as I said, is a permitted landfill. It is designed to contaminate the surrounding environment as little as possible. So if you think back to when we learned about soil and we talked about the fact that clay is frequently used to line landfills, and that's because it doesn't allow water through easily. So a sanitary landfill is usually lined with clay, and that's this brown layer here. Sometimes they're lined with plastic, not very often for large landfills, but sometimes they are lined with plastic as well. Above that layer of clay, there's usually going to be a layer of sand, maybe a layer of landscaping fabric or some sort of synthetic fiber, followed by another layer of sand. And the idea is that the sand allows water to percolate through. And so these sandy areas are run through with what they call leachate pipes. And so any water that comes through this compacted waste in the landfill is collected in this sandy area and collected by the leachate pipes and held in by this clay liner. So that deals with the leachate part of the problem. By collecting all of the leachate, then it can be analyzed for any contaminants in that water and can be properly treated before it's disposed of. As part of that process, landfills usually have what they call leachate wells, and they're just monitoring any water that gets outside of that clay liner. They also test the leachate itself that is captured. The other piece of landfills that is a pollutant issue is the gases. And so sanitary landfills actually have pipes running through them to collect the gases as they're generated. And depending on the type of landfill, it can either be pumped up and used to generate electricity, and that would be a natural gas type of electricity generation, essentially, because methane is the primary component of natural gas. It may be piped to another facility to generate electricity. In some cases, it's simply burned. That does produce carbon dioxide as a pollutant, but carbon dioxide is a much less significant greenhouse gas than methane is. So it's better to burn it and produce the carbon dioxide than it is to simply release the methane into the air. So that's the sanitary landfill. Sanitary landfills, it is anaerobic decomposition largely. Anaerobic decomposition is slower than aerobic decomposition. So depending on the composition of the trash and whether or not the conditions meet the needs for microbial decomposition, things might decompose faster or slower. Temperature also affects this. But you'll notice that things like plastic bottles take 450 years to decompose. That's slower than metal. So we don't want to rely on decomposition to solve our trash problem. So what are some of the other ways we can dispose of trash? Well, we have the idea of waste to energy, where waste is burned in order to create electricity, to generate electricity or heat. Um, and this is used in some areas. The benefit of incineration, there are several benefits of incineration. One is that you're generating electricity. Another is that although there is some ash left over, that residual material that does not burn, it is significantly less in volume. And so it requires less space in a landfill. The downside of incineration is obviously it's going to produce greenhouse gases. It may, depending on the content of the trash, also produce much more significant toxic gases or toxic pollutants. So mercury is one that can be released through incineration of municipal waste. Okay, so there's a lot of things that can't go in the trash. I picked this one. This is actually Vermont. And you notice they have a huge list of things that should not go in their trash. They ask you not to recycle or not to put your recyclables in the trash, but instead to recycle them. They ask you not to put compostable material in the trash, but instead to compost it. Now, we don't have a regional composting system here. We used to have regional composting for yard waste. We do not have that currently, but we'll talk at the end of this about how you can compost at home and what the benefits of that are. Now, the rest of this is very similar to what's banned in Virginia. You should not put these things in your trash can, not paint, not tires, not oil, not anything containing mercury, including compact fluorescent light bulbs. Don't put your electronics in the trash can, or batteries, or appliances. And the reason for that is that these can release hazardous waste, particularly mercury products, electronics, oil, and batteries, as well as the paints and stains. So these things can be disposed of, but they usually have to be taken directly to the landfill so that they can be processed correctly. So this was a question in 2016 on the AP Environmental Science exam. They said many landfills do not accept used tires, so they're often dumped in poorly regulated piles, and it asks to describe one human health problem associated with piles of discarded tires. So I bring this up because this was absolutely an out of left field question. Nobody expected it, nobody prepped for it. There's frequently a weird question like this on the AP Environmental Science exam. It's a question you can't predict or plan for. And it requires you to simply be logical, to think about what you know, to think about this is a practical experience. And here in this area, I would hope that you all know that anything that can hold water becomes a breeding ground for mosquitoes and other insects that can be disease vectors. Burning rubber also releases air pollutants that are hazardous to humans, and so that was also an acceptable answer. Here's the good news. While tires themselves are a huge problem for pollution, it turns out that they can also be part of the solution. So this article cites a study in Guatemala, so a Central American country where you have a lot of mosquitoes and a lot of dengue fever, which is a disease carried by mosquitoes. And they actually used old tires to create mosquito traps, thereby helping to reduce their mosquito population. So with enough innovation and enough creativity, we can take our problems and turn them into solutions. So that's our standard municipal solid waste. Then there's this category, e-waste. E-waste is only 2% of the entire municipal solid waste stream, but it is a huge concern. And why is it such a huge concern? Because it contains things like lead, arsenic, selenium, flame retardants that are persistent organic pollutants, antimony trioxide, also a persistent pollutant, although not an organic pollutant. Cadmium, chromium, cobalt, mercury, all of these heavy metals that when they leach out become the toxic materials in the landfills. A major concern here is that the US mostly does not deal with its own e-waste. We ship it to other countries. And so it winds up in landfills in countries that are not as strictly regulated as ours. And therefore, all of those toxic materials wind up in their water systems. So if we were to look at an iPhone, this is an iPhone 5. I know that's an old iPhone. But if we look, contains bromine, chlorine, lead, mercury, lots and lots of human health hazards. And so if you simply dispose of your old iPhone in the trash can instead of taking it to a recycling event, all of those toxic chemicals can leach out. Okay. The one other major issue with solid waste, less of an issue in the United States, but used to be an issue, is ocean dumping. In 1972, this was banned by the Marine Protection, Research, and Sanctuaries Act, but it still happens in different parts of the world. And this act went into place in 1972 because in 1968, the US reported dumping 38 million tons of dredged material, 4.5 million tons of industrial wastes, 4.5 million tons of sewage sludge, and 500,000 tons of construction and demolition debris. In addition to that, the US has in the past dumped radioactive waste into ocean sites, both in the Pacific and the Atlantic Ocean. So all of this solid waste needs to be dealt with properly and safely and on land so that it does not become an aquatic problem. So we've talked about what the waste is. Let's talk about how we can reduce it. So it turns out, not terribly surprisingly, that the amount of waste that's produced by a nation is directly correlated to that nation's gross domestic product. In other words, the more wealthy the country, the more waste. So why is that? Well, industrialization gave us new materials technology, gave us access to energy sources. And as a country industrializes, they have a cultural shift where convenience and speed are prioritized, and we tend to outsource and externalize our costs. And so developing countries increase their municipal solid waste, and we export our manufacturing and disposal. There's a fantastic movie out there called Fast Fashion that talks a great deal about the influence of fast fashion on this disposal issue, and hopefully some of you will take the time and check that out. So let's take a quick look at what it is that we throw away. So the number one thing that is thrown away in the United States is paper and paperboard. It's 27% of our municipal solid waste. Food waste is only 14%. Plastics are 13%. And then you can see there's a breakdown there of the plastics. So these things put together are 50% of our trash: plastics, food waste, paper, and paperboard. How much of that do you guys think is recycled? Well, 1/3 of our municipal solid waste is recycled, but 75% of that is paper and food waste. So over the last 50, 60 years, our paper recycling has skyrocketed. Our plastics recycling has increased. Our glass recycling has increased. But in the last 30 years, our aluminum recycling has actually decreased. And aluminum is one of the materials that is most energy hungry when it comes to production. So this is a little bit concerning. So when it comes to addressing and reducing our solid waste, what can we do? Well, the number one goal would be to reduce rather than recycle, and we'll talk about recycling in a minute, but recycling is not the ultimate solution that we might have been told that it was 15 or 20 years ago. It is still incredibly important, and I strongly encourage you to continue to recycle. But even better than recycling is reducing, meaning using less. So let's use less waste material in design and manufacture. So I just have a few pictures here. Some of these might seem a little silly, and some of them I am sure that you have seen. So this one just is kind of mind-boggling. We have a soda can packaged in plastic and wrapped in plastic. And this is found on a shelf in a grocery store. I'm sure that many of you have bought electronics that come packaged like this. This is simply a brick, and yet it is in a box 10 times its size, packaged with foam. Here we have two tiny little bottles packaged in two cardboard boxes and surrounded by paper. And again, 4 ink cartridges, and yet they required 4 separate boxes, each of them packed with paper. And then this one is probably the most mind-boggling of all to me. I mean, it's a banana. It has its own wrapper. It does not need to be packaged in plastic. So anything we can do to reduce the amount of packaging is going to help with reducing the amount of waste. And reducing is always better than recycling, because even recycling requires energy, and reducing just reduces the amount of energy, reduces the amount of material, reduces the amount of space. So best solution all the way around. Now, if we can't reduce, maybe we can reuse. We can make things stay in the system for longer. Best if that doesn't require a lot of additional energy. So we can upcycle. We can use our Starbucks cups to hold pens and pencils on our desks. Here's an innovative solution for what to do with all those tires. Someone's turned it into a garden exhibit. You can reuse light bulbs. You can reuse milk cartons. These people have had some fun decorating for Halloween. So anything we can do to reuse. And then the third piece, which should be our last choice, but still an important choice, is recycling. When we recycle, we're taking a material that has been used, or maybe a material that hasn't been used, and we convert it back to raw materials, which can be used to produce new products. And there's 2 kinds of recycling. There's what's called open loop recycling, where you convert material into a new product. So a great example of this is when you see a jacket or a blanket or something and it's labeled that it was made from plastic bottles. So recycling plastic bottles, PET bottles, can actually be made into fiber for clothing. Downsides of this, it does require energy input, still produces some waste, and sometimes the quality is not quite as high. But it still prevents a whole lot of material from winding up in a landfill, and it prevents us from having to harvest new material, which especially in the case of plastic means petroleum, so we want to stay away from that when we can. So that's open loop recycling. Closed loop recycling is taking the material and breaking it down and remaking the same product. So classic example of this, of course, is aluminum cans. Those get melted down and made into new aluminum cans. You can do the same thing with carpeting, as well as with some plastics, and certainly with glass. So pros of recycling: Well, we consume fewer raw materials, which means less mining, less pulling of materials out of environments. We can reduce the use of energy in manufacturing and in processing. We reduce the need for disposal, so fewer landfills, less space taken up in landfills. And of course, there's a decrease in pollution and emissions. What are the cons? Well, it's not necessarily all that cost effective, especially single stream recycling. Often recycling sites can be dangerous locations for contaminants and emissions for the workers there or for the nearby areas. Newer products are generally not quite as high a quality, maybe not quite as durable. It can be difficult to implement on a large scale or in certain areas. Many plastics aren't recyclable. And this is the biggest one, this false sense of security. It's okay if I drink my water out of a plastic water bottle because I can recycle it. No, it's not. Even recycling that water bottle is still going to, only about a fifth of it is going to be able to be reused, and it requires a lot of energy. So, this is where we exist now. Most of our waste gets landfilled. Some of it gets converted, some gets recycled or composted, and there's a little bit of reduction. The paradigm shift we really need to see is to focusing on reducing, then recycling and composting, then conversion technologies, then landfilling. Okay. One more, composting. So when we talk about composting, this is the creation of humus or organic material from waste. It is decomposition under controlled conditions. It requires aeration, and it produces an organic rich material that enhances soil structure, cation exchange capacity, and fertility. So it requires some attention. You have to layer dry material with wet material. You have to rotate and aerate, because if you don't, it's going to be like decomposition in a landfill and it's going to produce methane. And that's a very dangerous greenhouse gas. Drawbacks of composting can be odor, because you do have organic material breaking down. It can draw rodents because they're drawn to a food source. Okay, and we're going to stop here for now, and we'll follow up with a little bit more about the different acts that are responsible for administration of solid waste tomorrow.